All right, so number 6, we're on part 2 now of the same video, same PowerPoint as part 1. We're doing applications and solving rational equations. So let's take a look at number 6 here. Tommy can stuff envelopes 3 times as fast as Bernie. Together they can stuff 5,000 envelopes in 4 hours. So how long would it take Bernie to do it alone? And again, we're still using the same concept where the rate is the distance divided by the time, although in this particular example, we're not talking about a distance, we're talking about the number of envelopes in a certain period of time. And so it's going to look something like this. We're going to have the rate of Tommy plus the rate of Bernie would be the rate of them doing it together. And so together it says they can stuff 5,000 envelopes in 4 hours. So I'm going to start with this rate right here. 5,000 envelopes, together they can do it in 4 hours. And so what we want to do is figure out Tommy could do 5,000 envelopes in a certain amount of time by himself. Bernie can do 5,000 envelopes in a certain amount of time by himself, but those times are going to be different because it says that Tommy can stuff envelopes 3 times as fast as what Bernie can. And so let's say that Tommy stuffs 5,000 envelopes in X hours. Bernie's going to take 3 times as long, or 3X. And so our equation looks like this. And what I want to do is get the denominators to all be the same. And so, and actually maybe on this one I'll just get these two to be the same. So that would mean that I would need this to be a 3. I need to multiply the 5,000 here by 3. So 5,000 times 3 is 15,000. 15,000 plus 5,000 would give me 20,000 over 3x. And that's going to equal my other proportion, which is 5,000 over 4. And now I'm going to cross multiply. If I take this cross product here, 3 times 5,000, well, that's 15,000 times x. That equals my other cross product. 20,000 times 4 is 80,000. So if I divide both sides by 15,000, I'm going to get that x is 5 1/3. But I want to make sure that I'm answering the question. It looks like, I didn't have the 3 here originally, Tommy doing it by himself would take 5 1/3 hours. However, if the question was, how long would it take Bernie to do it by himself? Well, Bernie would stuff 5,000 envelopes in 3 times X. Well, that's 3 times 5 1/3. That's 16 hours if he were to do it by himself. All right, let's take a look at our final question here, number 7. Zach can mow twice as fast as his brother Jacob. Together they mow a yard in 3 hours. How long would it take Jacob to do it alone? So this is very similar to the last one. Again, we're dealing with rates. Rate is normally the distance divided by time, but in this case, it's the lawns. I'll say it's L divided by a certain amount of time. And so we're going to have the rate for Zach. So I'm going to say the rate for Zach plus the rate for Jacob would equal the rate of them doing the lawn together. And together it says that they mow a lawn in 3 hours. So 1 lawn in 3 hours working together. Well, Zach can mow the lawn in a certain amount of time. Jacob can mow the lawn in a certain amount of time. But those times are different. It says Zach can mow twice as fast as his brother Jacob. So let's say Zach mows the lawn in X hours. It would take Jacob 2 times that. Twice as long as his brother Zach. So again, I'm going to get the denominators to be the same. I'm going to put an x or a 2 here and a 2 here so that I have 2x in both of my denominators. So I'm going to have over here I'll have 2 times 1 is 2 plus the 1 is 3 over 2x. That equals 1 over 3. And if I cross multiply, here I will have 9 equals 2x, which is my other cross product. If I divide by 2, then x is equal to 4.5. Now 4.5 is what Jacob's rate, or what Zach's rate would be by himself. His rate was 1 over 4.5 hours. Jacob is going to be 1 over 4.5 times 2, which is 9 hours. So how long would it take Jacob to do it alone? Well, that's going to be 9 hours. So hopefully you get the idea of what we're doing here. This is assignment number 9, the last assignment in rational expressions. Good luck on your homework assignment. If you have questions, we'll go over them tomorrow in class.